Hello, everyone, and thank you for being with us tonight. I am pleased to present Professor Venko Beshkov. Professor Beshkov, could you please introduce yourself in a few words first?
Yes, of course. Thank you very much for the invitation and the opportunity to share my experience and my scientific results, at least some of them, with your partners. The reason why I was invited here is a project of mine titled Energy Production from Hydrogen Sulfide in the Black Sea Marine Water by a sulfide-driven fuel cell. Well, I shall talk a little bit about that later, but now let me introduce myself. So,
yes, thank you.
Here are the questions you put me some days before. So I was born in 1946 in Sofia. Quite impressive age, isn't it? I'm Bulgarian, married with one son, and I'm interested of other things than the chemistry. I'm interested in history, yoga, Eastern philosophies, and music. I speak some languages well or not so well: English, Russian, French, German, and Czech. And my scientific interests are in mass transfer operations. Those are processes which take place in chemical equipment, in chemical industry, in the energy production, etc. Environment protection from the point of view of designing and building and operating equipment which protect the environment from harmful pollutants like in air, water, and soil. Later, I started to work on recycling of industrial waste to extract some valuable components from the waste. The most recent research was dedicated to renewable energy sources, I mean, biomass utilization, and the project with the hydrogen sulfide is in the same category. Some bioprocess engineering, biotechnology for biochemicals production, wastewater treatment, gas pollution removal, etc. Well, the next question was to present my short CV.
Yes,
I was graduated.
I will just interrupt you for a second, but this question is basically because we are interested to show young people what your path is so they could potentially follow it one day. So yes, please, you can go ahead.
I can go ahead.
Yes.
So something about my education and my career. I was graduated in chemistry in the University of Sofia in 1969. My first interests were dedicated to the physical chemistry, namely in colloid chemistry. Then I started to work in hydrodynamics and mass transfer. And this skill of mine helped me to be appointed further in the Institute of General and Inorganic Chemistry at the Bulgarian Academy of Sciences, where I defended the PhD thesis on the surface phenomena and mass transfer in thin liquid films. It is a situation which is frequently met in heat and mass transfer operations in chemical industry and energy production. I was promoted as an associate professor in 1984 in the same laboratory in the later Institute of Chemical Engineering and at the Academy. And then I started new research in the area of biotechnology for fine chemical production and environment protection, where I still work for more than 40 years. In the period of 1999-92, I was appointed as a Deputy Minister of Environment in the Bulgarian government. It helped me, it prompted me to improve my attitude toward environment protection and give me a new philosophy, which I follow up to now. Then I was head of the Institute of Chemical Engineering at the Academy for 21 years until 2014 when I was retired, but I'm still working. I was elected as full professor in 1997. I was reader in different universities in Bulgaria for more than 35 years. And I'm still working on my research, my interests, which are again renewable energy sources. And the next question is, what about my invention on hydrogen sulfide?
Yes.
Here you can see what is a fuel cell. A fuel cell, it is a device aiming to convert the energy of a chemical reaction into electricity. It means that if you ignite hydrogen, it will react with oxygen. With explosion, you see some energy release as a heat and mechanical energy release. But it is more useful to use it in a fuel cell passing through the cell, and the energy of this reaction it is controllably used as electricity. Here we have liquid phase fuel cell where a solution containing hydrogen sulfide is passed through the anodic compartment, reacting and giving sulfide. It means that from hydrogen sulfide we produce sulfuric acid and some energy is released.
Yeah.
In the cathode compartment we pass oxygen. So because of these two reactions, electromotive force with delta U, which is noted here with delta U, which is about 1.08 volts. And so we can control these chemical processes in a way to produce electricity.
Mm-hmm.
How does it looks like on how it must look like? First, we pump water from the the big depths where the concentration of hydrogen sulfide is considerable. Then we pass this solution through the fuel cell. We generate the electromotive force, and already treated water is inserted again in the deep waters. So with this electricity, we can supply the grid directly to the grid, or we can split water by electrolysis to produce hydrogen and to store it or to handle it in the way we want. Here on the left-hand side is shown an illustration of a rig web platform for extracting oil or gas from the seabed. Our equipment will be similar to this. It will look like such a rig. It will be installed on a rig.
Yes, I see.
Where the hydrogen sulfide comes? It comes, according to my opinion, and there's different opinions, but I'm a militant of this one.
Mm-hmm.
The big rivers in Europe, the Danube, the Ukrainian rivers, Dnieper and Dniester and Don. Don is Russian, sorry. They sweep a lot of organic waste into the sea. This organic waste serves as a feed for the plankton, which is proliferated, consuming the oxygen in the seawater, and therefore at the bigger depths, this oxygen cannot be restored. And in this anaerobic zone, but there are bacteria which use the sulfate ions, which are inherent to the seawater, are reduced to hydrogen sulfide, and so in the bigger depths there is a lot of hydrogen sulfide. How much? Let's see here. The amount of hydrogen sulfide into the sea, their estimate from 2007, there is a 4.6 gigatons, which is equivalent to this amounts of other fuels like hydrogen, gasoline, natural gas, and as electricity, it is equal to 31,000 terawatt hours. For comparison, the annual energy demand for Bulgaria is about 15 terawatt hours. It means that there is a huge amount of energy, 2,000 times more than the demand of Bulgaria for 1 year.
Yes. Wow.
It is just to show you that this is a very significant and important energy resource, which is not just for a game and some scientific interest to be met. Moreover, there is each year new 75 million tons of hydrogen sulfide are accumulated, which are equivalent to this amount of natural gas. Again, much about tenfold larger than the annual energy demand of Bulgaria. Now, these figures might be changed because of the political and geopolitical situation, but nevertheless, the figures are figures.
Yeah.
What are the advantages of the proposed technology compared to the existing ones? So with red, I have marked the features for the high sulfide-driven fuel cell, our technology, compared to the other ones. Starting first with do I speak too fast?
No, it's a very good pace.
Okay.
Yeah.
So here we have comparison with traditional thermal power stations, which are supplied by oil, gas, or coal. Carbon emissions, you know pretty well that there is a carbon dioxide due to the combustion. Production is expensive. There are quite heavy operations. They have a long switch on-off process. You cannot stop this power station when the energy you produce is not necessary. Light in your room. It takes months of work on it. It could be switching. There's some ashes, some residues, which is necessary to be stored or treated somehow. There's must be a storage place for the fuel, oil or coal. So there is quite complicated production. Even we don't have any idea of that. We just use the heat and the electricity. Don't pay attention. How do they come?
Yeah, it's true.
What about the nuclear power station? See, first we have very expensive fuel production. We don't think about that. We just speak about the price of the energy, but we don't think about the whole processes of fuel production and concentration. Heavy operations, and again, we have very long switch on-off process. You cannot stop it the moment you want. Quite hazardous operations. We know about 2 accidents during my lifespan. This is Chernobyl and the Fukushima disaster. And again, we have big problems with radioactive waste storage. We have, in our case, we have less operational costs. EV switch on off, no hazards, no waste. About the wind and solar technologies, both are weather and season dependent. Is there windy weather or sunny weather? And they have also harmful impact on environment. Nobody speaks about the harms that the solar, the photovoltaic equipment goes to the soil below there, and depletion of the soil and all natural life within. On the weather.
Yeah.
Now, the question is how this invention may change Bulgaria and even the world. I don't think we can change the world because hydrogen sulfide is a local energy source which is concentrated into the Black Sea.
Mm-hmm.
There are some smaller amounts in other seas like the Baltic Sea and Caspian Sea, but let's talk and think about the Black Sea and the coastal countries, which are
Yes.
interested of that. First, it may be used and it behaves like a battery of electricity. We can switch it on and off in the way we want. Where there is a necessity of energy supply, so we can switch it on. If there is a overproduction and we don't need this amount of energy, we can switch it off, or we can regulate the capacity as it is shown here within the whole range of production.
Yes.
The other advantage is the drastic decrease of import of energy sources. What we do now, we produce pure electricity, and we can make some. We can spare some money for nuclear fuel and natural gas import. What is also very interesting and important, it is that the necessity of electricity supply because of the electromobile cars. We shall use it over and over, and the big progress in their demand and application. So we shall need more and more electricity to feed those cars. So we need more electricity and electrical energy for this purpose.
Yeah.
Next, this process is purely a green process because there are no carbon emissions in the air.
Mm-hmm.
There are no harmful waste discharged to the water. Therefore, it can be considered as a renewable energy source with very high capacity, as you have seen from the previous table.
Yes.
This green energy we can produce, we can sell it in a very attractive prices, low prices, so we can gain, we can conquer the market of energy to some extent.
Yeah.
And on the other hand, when we don't need to import oil and gas, so it means that we shall have a positive balance in our budget. So the deficit in our budget will be lower than now. Well, here I have shown the same things I have told you now, but here is the price of megawatt hours, which can be made in the year 2025.
Yeah.
So where we are here? Yes.
Yes.
What can I say to students who will be interested to work in the field I did? Well, I don't want to say that the research area I have worked is the best one, and that I cordially recommend it to anybody. But there are some things which are similar and common for all activities. Chemistry is a good science, but it cannot be used simply and only without combining with other branches of natural sciences. In my case, those are physics, microbiology, biochemistry, and technical sciences.
Mm-hmm.
Of course, it's impossible for a man to be expert in all these fields, but therefore there are teams which are composed with interfacial cooperation with experts in order to attain best result. And as a rule, leader of such a team must be one from a science or research area which is the most important for the project.
Yes.
It could be chemist, it could be physics, it could be engineer, but it is important to be the one who is leading for the project. What about the current opportunities in my area for young scientists? Well, I can say here with discontentness that there is no broad field of development for young scientists in Bulgaria in any is worse compared to the neighbor countries. I mean, Turkey, Serbia, not the European Union. And we cannot talk about the overseas countries like the United States, Canada, or Japan, South Korea. Why? It is because of the dismissive attitude of the Bulgarian society toward science and intellectual activity. I don't know if you have this impression, but I have seen that for the common Bulgarian people, the work with the spade is more prestigious and more important than the work with your head. And therefore, the budget for science is not so high as it must be. And for this year, it is 4.1% from the budget. And for reference, in India, the share for the science in their budget was 10%. So you can imagine why India is so well posed in the world, why so many Indians are everywhere, and why the United States are turning now to make India their most important partner in Asia instead of China. This scarcity of funds leads to low investments in scientific infrastructure, lower salaries, and therefore retreats of young people from research in natural sciences. So you have an idea, and you know how many young Bulgarian students are studying abroad. And why the immigration from Bulgaria is so intensive. And there is another thing which is not so associated with the dismissive attitude of the Bulgarian society. It is the lack of confidence of the investors and authorities toward innovations proposed by Bulgarian scientists. It is because I have such conversations and contacts with different people. For example, in a Bulgarian town in the province, the mayor and the city council are keen to pay much money for wastewater treatment plant, for example, imported from Germany or Austria on a much higher price. Instead of process, we can propose him, which is much cheaper, but they won't pay for sure.
Yeah.
In harmony with I have talked now, The financial situation is not brilliant, and because of these reasons, the salaries in the academic sciences are not so high as they must be. I'm quite cautious saying that salaries for senior scientists are below the average one in the country. They are much lower than that, these figures. What can I say to young people? Who would like to work in the field of ocean energy? The Blue Economies is your project entitled. There, both green and blue economies are very attractive because of many reasons. Because the resources are almost inexhaustible, and they can replace the polluting technologies on which our economy is based now. But we have to be always very careful about that human activities can destroy the environment balance. And there must be always a balance between the resources consumption and the rate of their restoration. So one must be always aware of the reproduction of species in the seas, not only fish, but even plankton, to be aware of the pollution and other harms that may be caused by the extension of human overactivity. All the problems you know about the micro-sized plastic particles which pollute the oceans just because nobody paid attention to that.
Yeah. Yes.
And now we are coming to the end. What do I want to add to anybody, to young people in particular? First, be yourself. Do not pretend to be someone else. And do never give up. What you start to work, do it until the last moment, and you will overcome all obstacles. I have many such cases in my life and my career, and I have been always granted of success at the very end. And thank you for your attention. This picture was made in the Black Sea during our expedition testing our project. It was many years ago on a ship of the Institute of Oceanology. So you see here a dolphin.
Yes, it's beautiful.
It was a video, but I couldn't mount it here. Just a steady picture. So thank you for your attention.
Yes, thank you so much for sharing your experience and also for being realistic, but finishing on this positive, encouraging note. Maybe just I would ask one last question based on what you shared. So I would say that I understand it's very difficult to pick up a path like yours in Bulgaria. But would you say there is hope? Are you feeling hopeful for the future? Would you advise young people to stay here in Bulgaria and try, or should they pursue this career maybe somewhere else in Europe?
Well, I can give you an example of my grandfather. It was very soon after the liberation. He studied music, opera singing, and music theory in Ukraine, Odessa and Nikolaev. He got a proposal to continue his study and career as a singer, opera singer in Vienna. He declined the proposal and came back to Bulgaria to become a teacher of music in the school. At the very end of his life, he said he did never regret for this choice at that time. So I can say that there is a very good thing that our young people are studying abroad, so they can bring their experience they got there, applying it in our life anywhere, no matter whether it was be art or techniques or economy or anything else. One more example. The Bulgarian state and the Bulgarian economy between the two world wars, the period of the 20s and the 40s, has been accomplished by young people who has been studying in Europe anywhere, or architects, engineers, lawyers, anybody has been educated and skilled in Western Europe. So this is the way. But how our young people will be attracted to come back? There are some people who come back. I don't know, but those who will come, they will have the big, what to say, they'll have the big objective to do it.
Yes.
But on the other hand, there is no such boundaries like had been before. So international projects that they can be or online projects, online discussions, what we do now, is trivial now. So there's another way to use everybody's experience and skill to develop the country.
Yes, thank you so much for this summary. These are all of my questions. Do you have anything else on your mind?
I think that the question you put me at last was the comprehensive one. So I think that's enough. I can speak on many things, but having this session and the topic of this session, I think that it is enough. If there's somebody to ask me, I'm open here.
Yes, thank you so much. So this was for our interview today, and I hope everyone who will watch this will enjoy it and have a useful takeaway and begin thinking of ways to develop their career as a scientist or something else connected to the blue economy. So I will stop the recording now.